And the audio
Getting IU or Purdue is better than
so it's like, it doesn't go anywhere. Yeah.
Well, and I didn't come to school. So I had to like I had to finish the book and then
They got Purdue nurses on them.
Yeah, they have nurses.
They're nursing.
Yeah, they're nursing.
All medical. They're gonna have all the engineers, biomedical engineers.
Yesterday.
Yo. Boys, let's hop it down. It's loud.
Yesterday, we talked about two types of sequences, and we had a couple of formulas. That one was for arithmetic, and this one was for geometry. Remember that from yesterday? And the difference is, in arithmetic sequence, we get from term to term by adding the same number. In geometric, we get from term to term by multiplying by the same number. Now, number one, right, our notes, 9.4, number one, we have this sequence. Now, there's some new vocabulary in here, so we all need to be paying attention. All right. Tell what type of sequence this is. So what do you think? This kind of sequence
Arithmetic.
Arithmetic. Because we are adding 4, so our common difference is 4. Now, it says give an explicit formula. This is what they mean by an explicit formula. I'm going to come back to my general formula here. And a sub n is 3 plus 4 times n minus 1. So what did I do? From this formula right here, I plugged in this. What does that mean? A sub 1, that is
The
first term. So I plugged in my first term. And then d is my common difference, which you already figured out was 4. Then I can do the distributive property. So a sub n is 4n minus 1. So to write an explicit formula, I use my general formula, the arithmetic sequence formula, but I plug in what I know. And what I know is that the first term is 3 and the common difference is 4. And then I just do from that. Now why is this called an explicit formula? Because if for some reason you want the 100th term, you want to know a sub 100, all you got to do is take 4 times 100 minus 1. So it's there, it's explicit, it's given, you don't have to work for it. You can just plug in whatever n you want. 8-inch Ace.
What did you do?
You want to turn around face forward?
What'd you do?
Focus. All right, so this, how do we find an explicit formula? We use our given formula that we know, and we plug in the first term and the common difference. Now, that's an explicit formula. A recursive formula says, how do we get from term to term here? What would be the next term? What would you do?
19.
It would be 19.
You plug in
Adding 4.
n.
No.
You're adding 4.
That's, no, if I want to use my explicit formula. But Jake, if I just want to look at this list of numbers, what's the next term?
19.
19. How did you get that? You just added 4. You took 15 and added 4. So what recursive says is, if you have some generic term, all right, I'll call it a sub n, some random term, to get the next term, all I have to do is add 4. What will the next term be? Well, this is where kids get a little freaked out because the notation looks hard, but it's very easy. What is the term after the fifth term? After the fifth term would be the sixth term. 5 plus 1, 1 more than 5. So what is the term after the nth term? The n plus 1 term. If that's 5, this is 6. If that's 7, this is 8, right?
Yeah.
Now, in order to use a recursive formula, you know you're adding 4, you're just adding 4, but you have to know where to start. So when you write a recursive formula, this would be your recursive formula, you have to include your starting point. Because all this does is tell us that we're adding 4. But I need to know what to add 4 to get started. So I'm gonna start with 3, and then I'm just gonna keep adding.
What's that formula called?
This is a recursive formula. This is your recursive formula. All right, let's try the next one.
Is it geometry?
Next one is geometric. Listen, kids, because it's new, does not give you the opportunity to sit back and say, I'm lost. Get over it. Pay attention, you'll get it, like you get everything else.
I'm
You're
gonna
smart.
have to
But you gotta quit the side conversations, and you gotta, as you guys say, lock in, okay? Now, next sequence, the directions say, what type is it? Well, this one is geometric, and it has a ratio of what?
1/2.
Be careful.
Negative.
Negative 1/2. The ratio is negative 1/2. See how it's going back and forth between positive and negative? So we're multiplying by negative 1/2. Now, I'm going to do my explicit formula. So to do my explicit formula this time, I'm going to use this.
Geometric is the right one, yeah.
So a sub n equals negative 2 times negative 1/2 to the n minus first. There is no simplifying. Don't do anything to that. That is your answer. How come I can't combine these?
Because there's a power.
There's a power, this one doesn't. They don't combine. If you combine them, you're going to be wrong. They will never combine. Never combine. So this is my explicit formula. Okay, this is my explicit formula. Now I need my recursive formula. Well, it looks confusing when you write it, but you've already told me what's going on. You said that I just keep multiplying by negative 1/2. So if I take my generic term, a sub n, and I multiply it by negative 1/2, it will give me the next term, right? What's the term that comes after the nth?
N plus 1.
N plus 1. So the n plus 1th term is just the nth term times negative 1/2. But always with the recursive formula, you have to tell me where to start. And I'm starting at negative 2. So this would be your recursive formula. Do you understand why it's not enough to say you just multiply by negative 1/2?
So where do we get the negative 1/2 again? That's just always
That's
there?
your ratio.
It's always there? Or?
No, it's the ratio. What am I multiplying by? This part.
Oh, I see. Okay.
Okay, I get that.
Wait.
Now, extra note, Fibonacci sequence. We're gonna do another one here, but I want you to know what the Fibonacci sequence is. Have any of you heard of it? The Fibonacci, Leonardo Fibonacci. Have you heard of it? Here's the sequence. about the Fibonacci sequence. It actually occurs in nature. If you are sometime walking around the woods and you pick up a pine cone, you know, a cone, so one that builds up from the bottom, you know, like a cone. If you count the kernels or the little things in that pine cone, they will often follow the Fibonacci pattern.
Oh.
If you look at a bee honeycomb, you know how they grow from the center out, they will follow the Fibonacci pattern. He actually first wrote about it when he was studying a rabbit population. The Fibonacci is a real thing. It's a real thing. There are books written about it. You can Google it. There's all kinds of information about it. What's going on there, Cinderella? What's happening?
One jumps, 3 jumps to the, and 8 jumps to the.
I have nothing.
It's adding, bro. It's like adding the last, like adding the last.
What?
one.
You just add the two next to each other.
Exactly.
That's not what she said. You said
What
jump
is
down.
2 plus
You said
3?
jump down.
Oh.
You said jumping down.
3 plus
That's
5.
8.
5 plus 8.
13.
Now,
Oh.
it's a beautiful thing. There is one huge drawback to
It's
Fibonacci.
exponential.
It is
Numbers get
written recursively. Because, stop. If I said to you, let's find the 100th term, how would you find the 100th term?
98.
Add 98 and 99, where would they have come from? 96 and 97. So in other words, there's no skipping ahead in Fibonacci. You have to build it up. And when we do that, the only way to describe that is recursively. So we're gonna write the recursive formula for this. Now this, it looks like this, okay, this kind of thing. So I'm gonna take my generic term, a sub n. Now what do I need to do to a sub n?
Add the term next to it.
Add the next term, and what will the next term be?
A plus 1.
N plus 1. And if I add those two together, like the 5th term and the 6th term, if I add those together, what will I get?
A plus 2.
The next term after that. You're getting it, Dana, that's exactly right. So if I add the 8th term and the 9th term, then I will get the 10th term.
The third term.
These are consecutive, n,
Oh, I
n
see.
plus 1, n plus 2. But, like all recursive formulas, I have to tell you where to get started.
What's the cheetah powder?
And why do I have to give you 2 this
Oh,
time?
because it's the.
Because it takes 2 to get the 3rd one.
You can't see that.
Okay.
You just have
These can get tricky,
There is a name on there, I don't know why.
so let's look at problem C.
You already done figured that. You saw it. Whoa. Oh, come on.
Now this one says, I only have to write an explicit formula.
What did we
The problem is it arithmetic or geometric?
hear about the other?
Arithmetic.
How do you do that?
It's not arithmetic at all.
Do I add the same thing to get from here to here to
No.
here to here?
No.
It's not arithmetic.
So it's geometric?
Do I multiply by the same
No,
thing?
no,
to
so it's
get from
Fibonacci.
here?
It's Fibonacci.
It's not Fibonacci.
Like what?
Fibonacci.
It's like adding the odds. I think that's wrong.
Well, you found a pattern there, but somehow you have to write that. If
Not
I
possible.
could really look closely at those numbers.
Oh, it's a 3, 5, 7.
9.
You
Oh,
increase
it's
by
backwards.
2. You increase by 2 each time. Every
That,
time you're at.
that, Elijah pointed that out, yeah. I'd like you to look at those numbers again, though.
It increases by 2 every time you add. Right?
Okay, yes, we've solidified that. I would, writing a formula for that, good luck.
Is it even odd, even odd, even odd?
Well, it is, but there's something very, very special about these numbers.
Oh, they're all divisible by
6, 8, 12,
You got
3.
They're not.
Just tell us. I can't do this.
No, you're all
Prime
no,
numbers.
please, no, they're not all prime.
Oh, wait, can we get an increase?
No.
Yeah, you can get it. Add 1 to all of them.
4, 9, 16, 25,
All square root.
30. Oh, they're squares.
They're all perfect squares. So these numbers are simply n squared
Minus 1.
minus
This is gonna
1.
be 82.
Oh.
This is gonna be 82. So it'll be 81.
These are the squares minus 1. So 1 squared minus 1,
Okay.
2 squared minus 1, 3 squared minus 1. So your explicit formula, it's not arithmetic, it's not geometric, it's n squared minus 1. Now,
What is that?
I am not at all diminishing the observations that you guys made about you could predict what would come next because you found a pattern in the additions. My caution to you is you're supposed to be writing a formula for that.
Yeah, we can't write no formula.
It would be tricky.
Yeah, I'll let you try.
I'm not saying you can't, but it's way harder than this. Okay?
So what is that? What is that called?
What?
What is that secret called?
It doesn't have a name.
Oh, so you get it. Okay.
Okay,
Oh, we're getting some stuff.
find the
I'll figure
first
that 2 weeks.
3 terms. Oh, this is easy.
Oh, this is so easy.
So a sub n is n plus 1 over n, and you're finding a sub 1, a sub 2, and a sub 3.
And 850.
And
A50.
a sub 50. Right?
Yes.
These are explicit formulas, so that's easy. A sub 1 will be what?
2 plus 2, which is 2.
Just 2.
Yeah.
1 plus 1 over 1.
Yeah.
So what's a sub 2?
3 halves.
3 halves.
Wait.
A sub 3.
Oh, I see. 10 halves.
3?
3 halves. 3 halves plus 1.
Three.
4 thirds. 4 thirds.
4 thirds.
3 plus 1
4 thirds.
over 3, so 4 thirds.
Wait,
Yeah.
yep, 10 halves. Wait, so is it 3 halves plus 1
No,
over?
it's 3 plus 1 is 4 over 3. 51 over. It's
A sub
it's
3.
n.
Oh, you only do the, yeah, you only do the first one. My bad.
51 over 50.
So the next one's gonna be 51 over, that, the 50th one is gonna be 51 over 50.
Yeah.
Don't make it hard,
Yeah.
for Pete's sake, just plug in N.
It's Ronan, dude. He's messing with my head.
Oh.
Alright, now you do B. Don't talk, just do B. Alright, what do you think? This is what I got. What do you
That's right.
think?
Yeah, it's
I
that's what I
reduced
got.
my fractions, you always want to do that if you can. Alright, now we have a huge section, determining whether these things are divergent or convergent. And if they are convergent, we're to give the limit. So, best thing to do here is to look at the first two, because they point out the differences. Look at the terms 1, 4, 9, 16, 25, 36. What's happening to those?
They're going up.
They're going
exponentially.
up and they are going up and up and up, right? They are diverging.
Yeah.
What does diverging mean?
Never ending.
Diverging means, yeah, just, when somebody says, I diverge, that means they're getting way off
Yeah,
topic,
yeah, yeah.
right? They're just out there. Divergent means your
Go on.
terms are going out. Yep, they're going away.
Bird means you go to
So, 3A is divergent.
Yep.
Okay, now let's look at the terms in B. 1/2, 1/4, 1/8, 1/16,
Going
1/37. Now, they're they're going down, but are they, think of a number line.
So they're not going to zero.
Here's 0, here's 1, here are your terms,
They're
right?
staying close to here, but never.
They get closer and closer to
Yeah.
0.
Oh,
Do
like
they
a-
ever go negative?
No.
Like an asymptote.
An asymptote. Oh my gosh, yes,
What?
that's exactly what
Heck
it is.
yeah.
It's an asymptote, and you're gonna see another connection in a
Yeah.
minute, but that's wonderful. Okay, so, question B, convergence. It has a limit, and its limit is 0.
So it's
The
convergent.
asymptote is like the limit. These terms are getting closer and closer and closer to 0, but they're never gonna pass it. Okay? So, let's take a look at C. Now, before you panic and freak out, you have seen problems like this before. Now, they had X's in them, not N's, but we all know letters don't matter.
Yeah.
And you graphed that. And when you graphed it, you put in a horizontal asymptote. That's your limit. Where is the horizontal asymptote?
Three.
Right there it is. The limit of sequence C is 3. It converges and its limit is 3. The horizontal asymptote is the limit, just like Roman said.
N equals 3.
So the limit is 3. Not n equals 3, limit equals 3.
We only want the horizontal asymptote,
The
correct?
horizontal asymptote, never use the vertical.
Next, this might be -2.
The next
It's
one,
divergent. Oh, wait, no, it is -2. You're right.
yep,
Yeah.
the limit of the next one is -2, so it's convergent. If it has a limit, it's convergent. Hey, put rock in my desk, okay? Those gonna last till I retire.
That's what I was.
How many, when are you gonna do that?
I don't know, 2 more classes like you guys, it might be sooner.
Maybe it's like
All right. How about
You
E?
should like retire with LeBron.
How about E?
Both the goats go down.
That would be crazy.
Aiden might.
What would be crazy about that?
Cause that'd be like both the goats.
Two goats retiring.
Both
Yeah,
the
the
goats.
goat freak
Yeah, I would
out.
probably- I would
All
say
right.
Ron's not the
How
goat.
about E?
4/5.
How about 4/5?
Yo, watch it.
It converges and its
Give me a
limit
note.
is 4/5. Are you seeing where these numbers are coming from? Yep.
Whoa.
How about F?
4/5.
I missed it. What was this one?
Hold on,
E
what was
was
D?
4/5.
Oh, my bad.
What was E?
Convergent.
Oh, there's no,
Limit
it's
is
divergent.
limit is
It's
negative
a
zero.
divergent.
Convergent and limit is
Who said
negative.
zero?
For D. For D.
Grace is right.
Oh.
F is 0. Why is F 0?
You plug in a 0 in.
Because we have 0n squared over n squared. Guys, this should all be coming back. This is stuff we did before.
I'm going with you.
How about G?
Undefined.
Well,
No.
divergent.
Yeah, divergent.
This sequence is divergent
And 0.
because when the power on top is bigger, there is no limit,
Limit.
no asymptote.
You
The
bet your ass.
horizontal
I already said
asymptote
it,
is
it's
the
there.
limit. Okay, what do you think about H?
I think it's growing.
Whoa, what is
It's
it?
growing. I think it's
It
divergent.
is divergent.
Convergent.
I think it's divergent. Wait, no, it's less than 1. It's convergent.
One or the other.
It's divergent because it's exponential.
No, it's convergent.
No, it's convergent because of the fraction in the parentheses.
Exactly. You guys, stop and think. When the
Outside, that's
power
what you do.
is less than 1, you have decay.
Oh, it's
So the limit is 0.
Try it. Try to.
When
Try
the
to. I'll give
base
it to you.
here, when that guy right there is less than 1, then your terms are getting smaller. That's called
Erase
decay.
the whole thing.
Now, what happens in I?
It's divergent.
That's divergent because that one is doing this, right? That's divergent. Either one or the other. They're either decaying to 0 or they're shooting up.
Now we're testing.
So what about J?
Convergent.
No.
No, I'd be divergent.
Divergent. Why is J divergent?
Because the fraction's positive.
5/4 is bigger than for one.
But what if it was like 2?
Stop. Okay, remember, we're talking about as n goes to infinity.
Yeah, because it's less than 1.
And if n can be 2, but then it's gonna be 3, and that's gonna be 200. And then it's gonna be 97,000, right? So that's what we're worried about.
Convergent 0.
Okay. Okay.
Convergent 0.
0. Divergent means you don't have a limit, so we never say divergent number. We say convergent, and the limit is 0.
Right, so this four, with the 2/3, if
That's
it's like
divergent.
3/2, which we had, would it be like a, it'd
This
be
is
that
what
one,
we
right?
have.
So wouldn't the limit be 0?
No, no.
No.
We're talking about what happens if
Oh, what,
n gets
oh.
big. We're letting n get big, so we're talking about what happens to the right of the picture.
No, that one's divergent.
Then how do you
What did we say about K?
Conversion.
Convergent limit 0.
Zero. Yeah.
Convergent, Jake, yeah.
No,
And
it's.
how about L?
Says different.
Divergent, which means no limit, right? Divergent, no limit. Okay, so are we good on all those? We got all the way to L, everybody catch all that? Okay, all right, you go lunch back at 45. Make sure you drop potty and take care of business. Nice prayer this morning, Jillian.
So it was like the principal day yesterday, so I told Rhonda that we would do it Thursday, so we have, class last Thursday, or tomorrow. So would I be able to like leave early tomorrow, like, cause I lost my
Yes.
good
Did she need you to do it yesterday?
She, she didn't need me to, but I wanted to just because I was like.
Yeah, so just remember, I will forget, right?
Yeah.
Just remember.